Hi folks, and welcome back to the video today where we're going to be focusing on pandas and geopandas. So the first thing I'm going to do is I'm going to open my Anaconda prompt, and I'm essentially going to go to where my actual files are saved. So I'm going to cd github cd satellite image analysis, and now I'm going to open up the Conda environment that I've been working in over the past couple of weeks, and I'm going to then begin Jupyter notebooks. So I'm then going to go into week 4, and I'm going to go into this one here, pandas and geopandas. And essentially what we want to do this week is just basically introduce this way of holding data. Okay, so you can hold data in a data frame structure, so you can think of this as a large matrix, a little bit like a very similar kind of structure to an Excel spreadsheet. And you can basically have items of data saved into certain columns, and then with one kind of entity of data stretching across each row. Okay. So you can look here at the Pandas documentation. There's plenty of information on that there. Today I'm just going to give you a bit of a whistle-stop tour of what you're able to do with this package. Okay. Now if you don't have Pandas installed already, what you need to do is you'll need to run this here with these first 2 lines unhashed so that you can actually install this Pandas package into your virtual environment. I've already installed it, so I'm just going to import what I've already installed here as PD, okay, standing for pandas. And the first thing we're going to do is going to work on actually creating a pandas data frame. So I've basically put a little bit of data here based on past satellite missions, some of them for remote sensing, imaging, communication, etc. And essentially they're basically lists with, in this case, strings or other numerical information, floats, booleans, or strings, okay? And hopefully you're able to actually create what I essentially have here, which is you're able to allocate each of these, in this case, list data structure to this variable named satellites, okay? And that should now all be in the actual memory for this Jupyter Notebook session. Next, what we're going to do is we're going to create a dictionary. We know it's a dictionary because it's got curly brackets. We're going to write the key here, and then we're going to give it the list of values for that key. So we have a dictionary which contains a list in the value position, and we're going to have the names of the column header in the key position. Okay, remember, dictionaries are always broken down into individual items, which is each row, and they have a key and a value. Okay, so this is what we basically end up with here once we've actually written that out. Now what we're able to do is we're able to use the pandas data frame function, which is able to take this dictionary and basically convert it into a pandas data frame. So when you look at this here, you'll notice that this is basically much more visually appealing for us to look at. It has like a dark grey background on one line, light white background on the other, so you're able to differentiate the rows nicely. We have each of the column headers nicely delineated at the top here, separate from the actual data. And we actually have the index for the overall pandas data frame over here on the left, so it's not a proper column, it's just referring to the actual index. Okay, once we've got that, what we're able to do is we're able to use the inbuilt function to_CSV to basically write this out to a CSV file in order for us to inspect that data, basically. So if I go to my file, I have that satellite missions data saved here. It included the index this time, and then all of the other 5 columns that I created have also been written to that .csv. So remember, CSV is comma separated value. So that .csv file, comma separated value file. Great. So that should give you your first bit of information in order to get working with pandas data frame structures. Okay, I want you to now have a go at actually creating this pandas data frame called image_data. have a go at trying to create it manually, and then afterwards we can have a go at looking at the answer. Okay, so just pause the video now, have a go at trying to create that, and I'll see you in a second. Okay, so I hope you all managed to have a go at that exercise. Let's tap out here the actual answer for this. So we get image data. We know that this is going to end up being a dictionary, and our first key is going to be ID, and then basically what we're going to have is a set of IDs from 0 to 3. The next is going to end up being the longitude. Okay, that's the key, and now the value here, we're going to have these numbers. So it's just easier if I copy and paste them. And then we're going to have the latitude. Great. So there's the first part of this. We're able to create this image data dictionary. Now what we want to do is we actually want to go pandas.data frame. I want to give it image data and then have that print, and hopefully it should be a pandas data frame. Yep, that's correct. And now what we want to do is we want to export it. So we go .to CSV, and we're going to give it the file name. So let's say we want to call it image data.csv. Let's run that. So I'm pressing Control Enter here. It's running everything that's in that specific cell, and then basically we're able to export that .csv file here. Okay, so we included the index that time. You are able to go index equals false if you like, and what that's going to do is it's basically going to ignore the index. It's only going to write those 4 columns which we essentially created. Okay, so I hope that that gave you the ability to understand what was necessary there for that particular question, that exercise. Now let's move on to actually accessing data. So essentially what we want to do is we want to actually explore what happens when we have a particular data frame. So in this case I'm actually using the head function, and what I'm doing is I'm saying I want to print just the very top of the data frame, so you get the top 5 rows or so. In this next case what I'm doing is I'm basically looking at the bottom part of the data frame. So you see the index here is only up to 4, whereas the index here starting at the tail is basically printing the bottom 5 rows. Okay, so we go from 8 to 12 when we just print the tail. Next we're able to look at the shape of the data. So this is basically saying that we've got 13 rows and we've got 5 columns. Okay, and then essentially we're also able to get the column names as we have done over here, and this is a NumPy array structure that you see here. It's saying that the index for the columns is this, there as a list basically, and then essentially we've got the data type here, and it's saying that it's an object. Next what we're able to do is we're actually able to go into our data frame and say we just want a specific column. So I mentioned before, it's not always the best way to kind of index columns by using numbers, because you might change the structure of the data frame. So what I'm teaching you here is to basically say, well, I want to index, so I'm using a square bracket after the data frame name, df, and I'm giving it the name that we want to subset, and it's giving me that particular column as a single array of data, okay, as a single pandas column. You can access multiple columns at once by subsetting the data. So here what we're doing is we're using 2 square brackets to say that from df we only want the column satellite and year, okay? And that's how we produce this simplified pandas data frame structure. Of course, you are able to index columns if you would like, using numerical information. So Here, I've just given an example of how you might select a specific row. So here we're using the .locate a function. So we're saying in the data frame, locate, and this is actually the position, the index position 7, which is the 8th row, I believe. So it's returning all of the information from that particular part of the list. Sorry, the particular part of the data frame. You can do the same essentially by indexing specific rows and ranges. So here we're saying we want to go from the 8th index location to the 10th index location. So it's just giving us a subset of almost the bottom of the data frame. And we are also able to subset based on particular continuous values. So here what we're saying is we want to go to our DF data frame. We want to access or index the information using the square brackets, and here we're saying that we want to do that specifically for those values, those rows which have a value in the year column that's over or equal to 2010. Okay, and when we do that, we end up with this this clipped version. So all of these years here are 2010 or over. Okay, so that's basically allowing us to subset on a single dimension of the data, one single column. We are able to do that in more complicated ways. So for example, here what we have is the ability to index the rows in our data frame, but we're actually doing that using two different columns. So firstly, we're indexing using those missions which have launched from 2010 onwards, whereas in the second part here, what we're doing is we're actually saying we only want to subset those missions which are basically the ones for remote sensing. Okay, so we're ignoring the others for communications or optical imaging, whatever. And it's just giving us two particular rows here that meet that condition. Finally, we're able to actually add an entirely blank column if we want to on our data frame. Sometimes you need to do this before you populate it with data. And here what I was able to do to create that was just state the name of the column that we want to add. And then we basically just say we're going to give it a string with 0 length. Okay, so there's no space here, there's no string in place, we're just basically leaving it empty. Okay, so that's kind of the second part of this lecture today, and let's have a little play now with the exercises. Okay, so just take a minute to try and work your way through these, and then I'll go through the answers afterwards. Hi there, so I hope you managed to actually have a go at the things that, the exercise questions that I've placed up here. Let's have a look at those answers now. So we want to first print the shape of image data, and I've just used the shape function. It's basically saying that it's a 4x4 data structure. Now what we're able to do is actually inspect the head of the Pandas data frame, so we're just getting the top, in this case 4 rows, using that head function. And next what we want to do is we actually want to subset the file name column. Okay, so what we're going to do is going to state our data frame name, then we're going to go to our square brackets, we're going to say file name, as that's the column that we want, and that's going to subset it just like this. But what we'd actually like to do is convert that to a list. So we need to put the list on the outside, and we're actually able to produce the file names which were in that Pandas data frame column, but here they've been produced just literally as a list. Okay, so square brackets with all of those satellite imagery names just below. Okay, next what we want to do is we want to subset just the longitude and the latitude columns, and then use a new function called dict to convert the data frame of the coordinates. So we know that if we want to subset a data frame, we need a double set of square brackets, and then we need to specify the actual column headers that we want to subset. So longitude, latitude should subset just that information that we want. And the key point here is that it's currently in a Pandas data frame structure, and what I wanted to do was just go to the toDicts function that we have. So you're able to convert a Pandas data frame into dictionary into dictionaries, and here we're going to give it the argument records, and what this will do is it will convert our latitude, longitude coordinates into one row, into a dictionary per row, and then we're going to put them into an overall list. So we have a list of dictionaries as the overall data structure. Next, what we want to do is actually subset those latitude rows which are between a certain size. So we're going to subset, we're going to use square brackets, and then we're going to subset again. We're going to put the column name, which is latitude, and we're going to say that we want it to be over or equal to 1.5, and then we're going to need to, let's see if I can do this off the top of my head without needing to look. Yes, so basically we do that first subset, and then what we do is we string on another subset. So in the first one we're saying we want all the rows that are over 1.5 in latitude, and on the second one we're basically saying all those rows which are below or equal to 1.6, and we get these two different rows here. Now what we need to do is need to do the same for the longitude. My apologies, let me just get the name correct here. Perfect, okay. So we're able to get the exact longitudes between those two ranges here and just subset those final three rows. Okay, so I hope that was fairly straightforward for you to learn how we can actually subset data which is held within a Pandas data frame. The key way to remember is that ultimately we might be storing our imagery information in this Pandas data frame, and then we might be just going to get a specific subset of our overall images at a later date, which then basically enables us to kind of select those images that we want with certain characteristics. Okay, so let's move on now to geopandas. This is going to be a basic introduction, but essentially one of the things that you need to do because of a current conflict between geopandas, NumPy and Shapely is that you're going to need to downgrade your existing NumPy installation from 1.23 down to 1.21. So what I've done here is I've put an extra line of code in which will basically install in Conda in your virtual environment NumPy. It's going to downgrade it from 1.23 to 1.22, and hopefully now that should mean that we get proper functionality for geopandas. Okay, so run this code, get it working on your machine, and let me know if you have any further problems, myself or the learning assistants. So geopandas is great because we're able to actually store geographic information within a data frame structure, okay? You can go off and look at the large amount of documentation and materials that are out there for this particular geopandas module. It's increasingly common for it to be used by Python users to manage their spatial data, and it enables users to actually work with geoseries or geodata frames. And it provides a range of functions that we're able to use to do things more swiftly than if we didn't use geopandas. Okay, so we can very easily read in a shape file, so that might be like a point or a line or a polygon or a set of those different types of geometry shapes. We can just read those in using one line. We can then manipulate column data. We can create new columns, taking information from our underlying spatial data. And then we could easily change the coordinate reference system between maybe projected and unprojected coordinate references, and then basically we're able to write all of that information out to a Pandas data frame at the end. Okay, and that's really the power of using this particular approach. So within the actual folder on the GitHub, you should have a single shapefile for GMU, which you should be able to download. Okay, so I've got a version of that just here, this GMU shapefile, and if you actually just drop it into your either QGIS or into ArcGIS Pro, then you should just see this fairly standard box. I've just put it on top of GMU's campus, but it just gives us a way basically to start working with a very basic polygon. It's not complicated, it's just been created from about 4 or 5 points in order for us to just show off some of the functionality of geopandas. Okay. So look, what we're able to do to import first is we're able to actually get the current working directory of where this Jupyter notebook is. Okay, so sometimes you might need to provide paths to other folders. The easiest possible way to import something is by putting your Jupyter notebook and your underlying data file in the same directory, okay, the same folder. And then all that we have to do is we have to just direct the file name to Jupyter Notebook in the first place that it's going to look is in the current environment. So look, here what we're able to do is we're able to import OS, which is the operating system package in Python. We're able to use this get CWD, so it's get the current working directory function, and it basically is allocating here to this variable current directory, and I'm printing it, and it's saying that Ed is currently working on the D drive in GitHub in the satellite image analysis directory in notebooks and in week 4. Next, what we're able to do is we're able to take that current working directory path, okay, so that's to week 4, and then we're able to tag on the end the actual file name for the shape that we're going to be working with. So we've got GMU here, we're able to print and look at that, and basically this is going to be the path from which we're able to then import our first geometry shape in geopandas. So in the next part, what I'm going to do is I'm going to use that path to try to import this particular file. So the read file function is one of those things that just saves you so much time compared to trying to read in and process your shapes in other ways. So first what we're going to do is we're going to import the geopandas package as, in this case, GPD, so it's just going to be a way for us to shorten that full name, geopandas. And that's what we've got here, GPD. And we're going to use this function read file, and we're going to give it the path. And then the second argument we're going to give it is the coordinate reference system, so CRS. And then this string here basically says that the coordinate reference system for this underlying data has been specified as EPSG4326. Okay, and that's the same decimal degrees coordinate reference system that your standard GPS coordinates are going to be based in. Okay, and when I actually print that data that we've loaded in, we can see we have an index here, and then in the geometry column, which is the neat bit about geopandas, we can actually see our Shapely polygon object. Okay, so remember how last week when I was covering Shapely, I was saying to you that you were going to basically see that data structure of a geometry in capital letters, a geometry type in capital letters, followed by a set of tuple coordinates, and essentially this is that Shapely object geometry that you should now recognize. The only difference here is that it's actually in a data frame, which is different to how we were viewing it previously. Great, so you've loaded in your first file, that's great. And then basically that means that you can start now to play around with some of those geopandas functions that are provided just to make it a little bit more lightweight for us to do processing within, in this case, this Jupyter Notebook environment. So one of the first things you want to do is you want to just explore how we change the coordinate reference system. Okay, so I mentioned before that we were using WGS84, which is this EPSG4326 code. You can just Google that, and it's going to be one of the most common coordinate reference systems out there. But it is in decimal degrees, and therefore what we'd like to be able to do is like to be able to change it to a projected coordinate reference system that actually has the underlying units being measured in a meaningful measure, such as meters. Okay, from meters we can then get to kilometers, square kilometers, for example. So here what we're able to do is we're able to basically use this to_CRS function. It's saying, when I loaded this data in, I know the CRS was 4326, and now we're saying we want to convert this data to this new CRS 3857, and then Pandas goes off, geopandas goes off into its library and says what I need to do is a conversion from 4326 to 3857. And you'll see here when we've got the underlying data in decimal degrees, here what we've got are actual meters, okay? We've changed the underlying coordinate references into a type of unit which is much more meaningful for us. And once we've got that, we are actually able to then take the area of something. So what we've done here is we said go into data, go to the geometry column, and because this is a shapely object underneath in this geometry column, we can say dot area as a function is going to find the area of that shapely geometry, okay? And we're able to allocate that area to a new column within our geopandas data frame called area, and I'm going to print it here. And what you can see is you have the feature ID, which is 0, you have the geometry here with that shapely polygon object, and then finally we have this new area column, and this is in square meters, okay? So it's 2.76 to the 10 to the power of 6. So what's nice about that is we can then begin to actually do things with this area that we've measured. And one of the common things that you might want to do is actually convert from the underlying number of meters, in this case data area, we're actually going to need to divide by 10 to the 6 in order for us to basically get the square kilometre area. And that's square kilometres is probably going to be a relatively meaningful metric for most scientists who are working in spatial GIS activities, okay? And therefore what we want to do is we want to allocate that as a new column in our data frame. So we have an error. Doesn't seem to like what we just did. Okay, so that's the area. There we go, perfect. So what we're able to do here is then just print that single column afterwards. You can also print the whole data frame. Here we go. So we've got the geometry, the area, and the area squared at the end. Great. So we're able to look at that whole data frame. And now what we're able to do is we're able to actually iterate over that data frame. So in this case, we only have one row, but you could imagine a circumstance where we might have 10,000 rows, okay, or 1,000,000 rows. The point of this for loop for us to iterate over these rows is for us to be able to go through each individual row one by one and carry out a bespoke piece of analysis, okay, a bespoke piece of processing. And we could insert our own logic in here to work out how we want to process specific rows, okay? So in this case, what we're doing is we're using a for loop. We're saying for row in data, and then if it's a pandas data frame, you need to use the iter rows function, and that's going to say, right, this is now a for loop. Obviously, we have our indentation down here, which is either a tab or 4 spaces, and then we're just going to print the row in this particular case. What it's doing is it's saying the index here was 0, and then what we do is we have all of these other columns which were in the data frame, okay, and it's just printing this. That's basically everything that was available on the first row of that data frame. What we could do is we could index the row at 0, and it's just going to print the row index here, or what we could do is we could press 1 to index, which we get is just the row information of basically the column headers and the individual items of data. So hopefully that should be fairly straightforward. I just have a second example down here where we do more of that kind of indexing. So we actually index into the index here, and then we index into the underlying row information here, just using these square bracket examples. What we are able to do once we've kind of gone into that row information is we're then able to specifically refer to different columns, the information in a specific column. So remember here what we're doing is saying for row, and then we're indexing into it to get just the column information part, and then we're saying we don't want all of the column information parts, we just want the piece of information that's in the geometry column for that one row. And that's why we're stringing these together here to index in order to produce this final polygon. And what we end up with is this polygon shape being printed down here. Okay. So, bear with me one moment. Just want to check that we definitely got that correct. Perfect. Here we go. We can see that our data has coordinates for the projected coordinate reference system, which is in meters. Before it was incorrectly showing that it was in the unprojected decimal degrees coordinate reference system, so the numbers look different, and therefore I just want to check that we were in the right location. So once we know that, what we're able to do is we're able to say 4 row in data iteros, and that's going to get us the first row in our data frame, because obviously we're going to start at that position. It doesn't matter that there aren't any other rows at this point, it's just going to demonstrate that we have this loop. We're then able to basically say we want to go into this row information, we want to index to the actual column and value part, so we're going not to the first bit, which is the index, but to the second bit, which is the columns. We're then going to basically go to our geometry and get the area, and then we're going to divide it by, as this is in square meters here, we're going to divide it by 10 to the 6, and that's going to get us square kilometers. Okay, so we get area km squared. And then finally what we end up with is this area underscore km squared being round to 1 decimal place. And then we're just basically printing that area underscore squared here as part of this string. So the area of GMU's campus is broadly 2.8 square kilometers. Okay, so hey, I know that that was a lot of kind of information about how we program and actually kind of get specific information when we're doing things like we're looping over geographic information, but it's actually going to be really helpful to you when it actually comes around to carrying out your projects and actually being able to write code to manipulate a set of images which you've downloaded and processed and then will actually extract data from. Okay, fantastic. Well, thanks for tuning in today, and I'll see you all soon in the next video. Goodbye.